Hi guys, my name's Finn. I'm a flight instructor in the southeast of England, and welcome to this video. This is part of a series of videos called Grounded, which is basically about things you can do on the ground when you can't fly for whatever reason. Because the truth is really that if you want to be a good pilot, or even just good enough a pilot to pass your test and fly safely, then it's not just about turning up to your lessons on time and doing what your instructor tells you. You're going to need a depth of knowledge that you can show to that examiner and that you can pull on in later times when you've passed your test. And so the idea of these videos is just to go through things that you can do when you can't fly for whatever reason. Maybe the weather's bad, maybe the aircraft you're going to fly has had to go into maintenance, maybe your instructor's ill, whatever the reason is that you find yourself grounded. I really challenge you to make good use of that time, and instead of just going doing something else, do some other aviation learning. So that's what we're going to look at today. And in fact, to be more specific, what we're going to look at today is we're going to look at the POH and get to know your aircraft way better. Now, I want to stop there and say, if you've not seen the previous video where I set you a few challenges, showed you how to sort of find the instruction manual for the aircraft, if you've not seen that video and gone and tried to find those things I challenged you to find from the POH, then pause this video. So the first thing we said we would do is go online, go to Google or your favourite search engine and find the POH and just double check that you're using the correct one for the correct model of aircraft. This is the 1980 Cessna 152. Let's imagine that's what we're flying. If you're flying a different year one, see if you can find the particular year and correct model. Your flight school should be able to help you with this. Now, if you remember, the first thing I asked you to find was the fuel capacity, both the usable, unusable, and if there are any tabs in the fuel tank, which there aren't in the Cessna 152, I asked you to get that as well. So, first place we want to go to is the table of contents here, and for this we want to this is just general information. We might also find more information about the fuel systems in airplane and systems in section 7, but really this is probably just basic information we'll find in the general section. So off we go to the general section. Here's the table of contents here, and fuel right there, nice and obvious, is going to be page 1-3, and off I go to page 1-3. And here is information about the fuel. It tells us what type of fuel we should use, gives us a warning about additives, and then if we've got standard tanks, which double check with your instructor, your flight school, most of them will have standard tanks. It tells you the total capacity here is 26 gallons, but the total usable fuel from that is 24.5 gallons. So no matter how much we could fill it all the way to the top, we can't use that last 1.5 gallons. So that's the answer to that first question. Hopefully you found that pretty easily. The next thing to talk about is the maximum takeoff weight, which, as it happens, is probably also going to be in this sort of general section here. So if I go back to the contents of the general section here, you see here it says maximum certificated weights. So something makes me feel that's probably what we're looking for. So if I go to page 1-5 here, then you will see 1-4, 1-5, maximum certificate weights. The takeoff weight is 1,670 pounds. And same max landing weight. It's the same weight for both there. Interestingly, you notice the ramp mass, the max ramp mass, is about £5 more. So you can leave the ramp with a little tickle of extra fuel, about just under a gallon's worth of fuel, and you'll burn that by the time you've done your power checks and your taxiing to the runway, and that's why it's slightly higher. So that's how to find the maximum takeoff weight. Crosswind was the next thing I think I asked you to find. The maximum demonstrated crosswind. Now that's in the next section of the POH, in the normal procedures. So you see at the front here, normal procedures is section 4. So let's go and find section 4, the contents page, and so we've gone past the limitations and the emergency section, and here's section 4 and the contents of this. And it says here, there's a great page here that most aircraft POHs will have that says speeds for normal operations. So I'm going to head there and see if that's got what I want. And actually, if you see down here at the bottom, maximum demonstrated crosswind velocity 12 knots. So next time the wind is blowing at 15 knots across the runway and your flight instructor says, oh, it's too windy, but you see some pilots flying a maybe different or larger aircraft out there, you think, how can it be too windy? And so it's not always how strong it is, it's also the direction it's coming from. So this is the maximum wind speed that the test pilots were able to demonstrate safe landings when they certified it. Now, some schools will use this as a hard limit, some will use it as a soft limit, and you can go over if you're if you think it's suitable. I would, as a PPL, and even once you've passed for certainly the first several hundred hours, I would say consider this a hard limit. So that's the crosswind. Next thing I asked you to find was the rotate or lift-off speed, however it's described in your POH. And so normal operations is, again, normal procedures is the best place to do. And if you see here, there's a section here on takeoff. So if I go to page 4-8, then it should tell me all about how to do a takeoff. And so it says here, for normal takeoff, make sure your wing flaps are between 0 and 10 degrees, car beat cold, throttle fully open, and then elevator control lift nose wheel at 50 knots indicated. So that's our rotate speed, 50. And hopefully this aligns with what you are doing in your lessons. And this is exactly where everything your instructor is telling you about and everything on the checklist comes from this base document, the POH. Next thing I asked you to find was the best angle of climb speed. Now, that is going to be in a few places, but the best place is this lovely page here that tells you all the speeds. It says here, best angle of climb, 55 knots. And then I think the next thing I asked you to find is also on this page, which is the best rate of climb speed, which is given in as a range between 67 knots at sea level and 61 knots at 10,000 feet. Now, you'll also notice that 67, 61 probably isn't the exact number you're using in your training. I would hazard a guess it's probably been simplified to be 65 knots by your instructor or your flight school. So that's your VY, which is kind of the speed you climb at most of the time. Next thing I think I asked you to find was the best glide speeds. Now, it gets a bit interesting here. We start to go into the emergency procedures. Sort of skipped past this a little bit. But if I go to the section before this, section 3, the emergency procedures, the contents page here, pretty near the top, because pretty important emergency to deal with would be an engine failure. So let's see what it said about engine failure on page 3-3. It says here, engine failure immediately after takeoff, airspeed 60 knots. So we can probably assume that that's the best glide speed. It also says here, engine failure during flight, first thing to do is get the airspeed to 60 knots. So it sounds like that's probably our best glide speed. And actually, some of these emergency procedures, they've amplified. They've gone into a bit more detail. So if I go to page 3.9 here, see amplified procedures, engine failure 3-9, then you will see a bit more information about it here. Tells you a bit more about what to do in the case of an engine failure and tells you the speed, the best glide speed you should be doing at. Incidentally, say you're flying along at about 2,000 feet above ground, tells us here that with no wind and engine failure, you'll be able to glide about 3 nautical miles, which isn't really massively far. So keep that in the back of mind next time you're flying, and you can imagine a 3 nautical mile sort of circle around you. It's kind of where you're going to be landing if there is an engine failure. So that's the best glide speed. Next thing I asked you to find was the normal approach speeds. And again, I really recommend you go back to that brilliant speeds page down here in the normal procedures section. It says here, landing, normal approach with flaps, which is what we're doing, 55 to 65 knots. I imagine your instructor's probably got you using something in the middle or something near the top. Might depend on what the flight school want them to do. But yeah, 65 knots is probably a familiar figure for a normal approach with flaps. So that's where you find the information you want. More information, you can go down and look at the normal procedures here, and it tells you the normal landing procedures. Touchdown, main wheels first, lower nose wheel gently. Braking minimum required. So that's the normal landing procedures there. Next thing I challenged you to find, hopefully this is all a bit familiar, there's a couple of harder things I put near the end. The static RPM, which basically is the RPM that the engine will produce at full power, but without moving, i.e. static. So when we accelerate to full power on takeoff, this should be what the RPM gauge gets to before we really get moving. And as we do our takeoffs, if you're at that stage in your training where you're doing takeoffs, hopefully your instructor's training you to just double check that the power is set. But actually we just look and we say, oh, the RPM gauge is pretty high, must be all right. But what should you actually be looking for is, unless the plane's got moving a lot, should be something around this static RPM figure. So let's go find out what it is. So for this, I'm going to go back to the limitations section, a bit of the POH we've not really looked at too much. Oops, let's see here while I just scroll and find the right part. So it says limitations is section 2. So I'm just going to scroll down and get myself to section 2. Here we go, limitations. And these are all the limits that you've got to operate the aircraft within. So it's near the top of the POH, and hopefully it'll be familiar to you. First is airspeed limitations. So for example, your maximum flap extended speed is here. The speed you can never exceed is here. All this sort of stuff is all there. And here we get to power plant limitations. Hopefully this is the right engine for the aircraft you're flying, which is why it's really important to make sure you're using the right POH. And it says here the static RPM range at full throttle with carb heat off and mixture lean to maximum RPM is 2280 to 2380 RPM. So what that tells us is that really what we should be looking for when we apply full power is an RPM setting of around 2300-ish. Slightly more, it's fine. If it's more in the region of 21,000 RPM, then that's probably a good reason to stop takeoff and investigate further. So this is the static RPM figure we were looking for. And the last challenge I set you was a bit harder, was the cruise fuel consumption using today's conditions at 3,000 feet. A bit of a stretch maybe for depending where you are at in your training. But let's start off with finding information that's given to us in the POH, and then we'll find today's conditions and go back to it. So for this, we want to go to the performance section, which tells you all the facts and figures about how they would expect the aircraft to perform. If we go back to the table of contents here, you can see it's section 5. So I'll get myself down to section 5 in the POH here, and what we're looking for is the cruise performance. And actually, the performance, I think, certainly in this POH, is really good. This is the table of contents here. And before I go straight to the cruise section, it gives you a real good introduction. I'd really recommend you read this about how to work out the performance for all the different aspects of flight. It goes through, works it out with you, gives you examples. Essentially like a little textbook there. It doesn't just give you the bare information, it tells you how to do it. So I really like that part of this POH. And then we really want to be looking for the cruise section. This is about takeoff performance and climb. And this here is the cruise performance section. So we've got a couple of columns here. It says this is a column you use if the temperature is standard. This is what you use if it's about 20 degrees more than standard and 20 degrees below. And then you've got to choose your pressure altitude here. And in those columns, it'll be able to tell you your percentage of the brake horsepower. So how much percentage of the engine's power you're using, what your true airspeed in knots would be, and your gallons in US gallons per hour, how many you'll burn per hour. And this is the figure I'm after. So let's see. I said to use 3,000 feet. So that means we're going to have to choose the figure between 2,000 and 4,000. We have to look at both and pick a figure halfway in between. And also bear in mind that if the pressure is a long way from standard pressure, then you may not be at, if you're flying at 2,000 feet on a QNH, you might not be at a pressure altitude of 2,000 feet. Now, I don't want to get into that too deeply in this video, but I just checked the Gatwick QNH today, which is about 3 hectopascals away from standard 1013. It's about 30 feet per hectopascal, so it's about 90 feet. So we're not a considerable altitude away from this. In fact, if we were flying today on the QNH, we would be flying at a pressure altitude of about 1,915 or something like that. So it's not a huge difference. So we'll just round it to halfway between these two. And then let's see if we've got standard temperature. So standard temperature on the ground would be about 15 degrees. We'll look again at the METAR HIATES with 13 degrees. So we can reasonably expect it to be, that's within 2 degrees of the standard temperature. So I think we can reasonably expect this standard temperature column to be on the money. So we normally use a cruise power setting of 2200. And I've already said that I'm going to find it for both 2,000 and 4,000, take the one in between, and I want gallons per hour. So the figure I want here is 4.8, and the figure in this column, also at 2,200 RPM, is 4.6. So that gives us, if we take halfway between the two, would give us a figure of 4.7 gallons per hour. And there's a couple other things to note about that. It says here that if we don't lean the mixture properly while we're flying along, then we won't be able to get these. These fuel figures are for if you've leaned the mixture. You'll notice in our early days of flying that we don't lean the mixture, so we can use a bit more fuel. And I don't tell you how much fuel that is. From experience, I'm going to tell you, if you use 6 gallons per hour, that's a nice conservative figure for most operations in the 152. And that's how I would quickly work out how much endurance I have from fuel. But if I wanted more detail and I was going to lean properly, these are the figures I would use. So hopefully that has told you exactly where to find all those 10 challenges I set you. Hopefully it's cleared some stuff up if it wasn't already clear. What I'd really recommend is keep looking to that POH. Now we've done this exercise, don't ever not look at it again. It's really, really useful. And some of them, including the Cessna one, give you almost a bit of training about how to use the POH and how to work out performance itself. So hopefully that video was useful. Hopefully you've been able to get a deeper knowledge of your aircraft that you're flying that you can take to your next flying lesson and really impress your flying instructor. Thanks for watching.